Welcome to the fourth day of me solving an algorithm challenge per day. Today's algorithm is going to be between two sets. Alright, you will be given two arrays of integers and asked to determine all integers that satisfy the following two conditions. First, the elements of the first array are all factors of the integer being considered. The integer being considered is a factor of all elements of the second array. These numbers are referred to as being between the two arrays. You must determine how many such numbers exist. For example, given the array A 2 and 6 and B 24 and 36, there are two numbers between them, 6 and 12. 6 divided by 12 modulo by 12, 6 modulo 2 is 0. So there are two numbers between them, 6 and 12. Complete the get total x function in the editor below. It should return the number of integers that are between the sets. An array of integers, and let's see. The first line contains two space-separated integers n and m, the number of elements in the array A and the number of elements in the array B. The second line contains n distinct space-separated integers describing, okay, so 1 to 10, and then, so we can have between 1 and 10 elements per array, and each element could be between 1 and 100. Let's see again up here. So basically that means the first array is containing factors of an integer that we're looking for, which means, for example, if we were to look for 12, then 6 would be a factor of 12 because x times 6 can be 12, and where x can be 2 in this case, or 12 itself is also a factor of 12. 2 is a factor of 12, and even 3 is also a factor of 12 because 3 times x is 12 and 3 times 4, for example, would be 12. So we're looking for an integer from which the factors, the element of the first array are all factors of the integer that we're looking for. And then that integer that we're looking for should also be a factor of all the elements of the second array. That should be the factor, not like the factor of that integer, but the integer itself is a factor. So that means, we have the constraint here to up to 100, right? Which means I think we can go iterate from 1 to 100 and see whether we are ever having a case where all the operations are 0. Say 1 modulo 2, 1 modulo 6, 1 modulo 24, and 1 modulo 36 are 0. In that case, that would be the numbers you were looking for, I would say. And you would count up. Am I returning the amount of numbers? Sample output 3, print the number of integers that are considered to be between A and B. Okay, so yeah, we are counting up the numbers that are modulo 0. Yeah, I think that we can go for that and try. So let's see. We have for index, or we can call it index, it's not really an index, for counter, for number in 1 to 100, right? Because that was the constraint. Now, if number modulo, I'll have to go through all of them too. I feel like this is a pretty expensive loop that I'm building. because I want to go for a value in A, and then say if a value, damn, okay, I can probably append it. That would be like a for loop into a for, inside a for loop and then another for loop. I feel like there must be a mathematical operation to solve that too, but I'm not sure. I just feel like it. So then for a value in A, we can say if number modulo a value equals 0, let's have a variable where we have an array of, because we want to collect all of that. So then list append that number. So that would be just one condition that should be true. Damn. We should have it all be true. Like for number, I think what I could do is for a value here, I could say found A true false. I didn't found, no wait a second, I did found A true. And then say if number modulo is bigger, then we would say found A equals false. And after we're done, say if it's bigger than 0, that means like I tried, for example, for the number 1, I tried to see whether or not 1 is divided by a value having a rest of something. If so, then we didn't found an A. Then that number is, we can already return actually. We can stop right there. Are we returning? Yeah, we could return. Else, we can say we are continuing. I don't think I need a boolean. So then we loop through it and it went fine. And then we can say, okay, let's continue with that number and try in B value whether if B divided by, is it B modulo 12 number? It's number E value, then return. Oh wait, we don't want to say return, because if you say return, we're returning to the function. We want to say break, that's what we want. So we break out of the loop, and let's see, shall continue. I don't think if that's, whoops, the right approach. True, and then we can say here we're skipping, because if we found something that doesn't work, we want to break out of this loop. We don't need to loop further, and then we can also break out of, not break out, but just continue to the next number inside of this loop. If we found a number that works for this one, we won't continue here, and we can try whether we want to whether that number works for this one too. And basically here I only need to break, because then I'm breaking out of this loop and it continues down there. or let's say shall continue if shall continue equals true, continue, else we can count up. Let's say numbers 0, numbers plus equal 1. Now let's check, because I'm quite... do we have an example down here again? 2 and 4 divide evenly into 4, 8, 12 and 16, which means we are actually dividing by... and 4 and 8 and 16 divide evenly into 16. So this number. So we are actually saying that we want to have, yeah, a value modulo by number and b value by number, I think. And it should always be true for 1, right? Bigger equal 1. Why aren't we having 1 here? No, I do feel like it should be number. Right? For example, we have 6. No, because if we have, for example, say for this one, right? 24 modulo 6. That's this 24 is from here. Modulo 6. Which means this is the number 6. From here, modulo 2 is 0, 6. Why is it on the left side? Oh, this is on the left side here, and this should be here on the right side, right? Yeah, because we are looking for different things. Here, we're looking for the number being, what was it? The first array are all factors of the integer. So here, that one is a factor of that number, which means, okay, the number itself, or it could be a smaller number because this could be bigger. For example, 12 and this is 6. Here it's the other way around. That's why I have to switch this. This one, that one is a factor of this. Let's see. Damn. Missing return in function. Oh yeah, expected. So here, returning an int, return numbers, and run. Succeeded. Now that looks good so far. Let's submit the code. Bam! Alrighty, so that worked out on first run and first submit. Well, actually second, because I had the return value missing. Great, so that was the challenge for today. If you liked that video, don't forget to hit like or leave a comment, and also subscribe if you don't want to miss out the challenge for tomorrow. See you then.